Sorry about the obnoxious dog barking. So to go back to what I was saying is this idea of grouping our unit fractions to make a whole each time. So with halves, we know it takes 2 halves to make 1 whole. So then I can see that I have 2 halves. Technically, I have it 3 times. I have 1, 2, 3, 2 halves, which is the same as 3. So when I'm looking at this in my picture, I could see that there were 3 candy bars. I can see here on my number line, there would be 1, 2, 3. So 6 halves is the same as 3 wholes. And if you thought about what Miss Skoll taught with division, you could think, oh yeah, if I have 6 halves, really what I'm doing is I'm dividing 2 into 6. How many 2's are in 6? 3, and there's nothing left over. So that's going to come into play a little bit later, but ultimately I want you to see this idea of grouping to make whole numbers. So we're going to practice that a little bit more. So right now what I want you to think of is 10 times 1/5. So you can use the number line that's on page 119, or you can draw your own number line. And we know that we're going to make 10 1/5. So on my number line, I'm going to think, okay, well, I don't have any here, but I know I'm going to need to have 10 lines. So I'm not going to count that one, but I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. So what I'd like you to do now is, now that you have your fifths lined up and you have 10 fifths, you can see if I drew it like a candy bar so you could kind of see that as well. I have 1/5, 1/5, 1/5, 1/5, 1/5. There is my 5 fifths, but I need 10 fifths. So now I have another 1/5, 1/5, 1/5, 1/5, and 1/5. There's my 10 fifths. Okay, so what we're showing here is, again, this idea. I could have a whole bunch, in this case, 10 fifths. And I'd be adding them because we know addition is just fast multiplication. So I could rewrite my multiplication problem. Let's see how many I've got. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, I was short 1. So when I'm thinking about 10 times 1/5, it's 1/5 10 times. And if I add that up, I can see it's really 10 fifths. So if I think about grouping that like a whole, we could see right here, we would group 5 fifths together. So 1, 2, 3, 4, 5 of my fifths go together. There's 5 fifths, which is the same as 1 whole. And then another 5 fifths go together, which is the same as 1 whole. So that means I have 2 whole candy bars. 5 divided into 10 is definitely 2 with nothing left over. So when I'm thinking about that algebra concept that they wanted me to consider is, I really have 2 groups of 5 fifths. 2 times 5 fifths. So what I'm saying is that 10 times 1/5 is really the same as 2 times 5 fifths. We were just regrouping our units together so that I could see my answer would be 2. If the regrouping of these fractions is a little complicated for you, especially if you're not really understanding this idea of how did I start with 10 1/5 and then end up with 2 times 5 fifths, I don't want you to worry as much about that. What I want you to really contemplate and think about with this is 10 times 1/5 we know is 10 fifths. We can see it's 10 fifths. You guys know how to do that. And then you can think about it, fractions is a lot like division, and in this case it's really a division problem. So now what we're going to do So we've looked at a couple different examples using a number line, using a tape diagram to represent our fraction so we can see how it relates to a number line. On my number line down here, I can see exactly how it would line up. So what we're going to do now is we're going to take a look and we're going to practice this more of a mathematical way. So what we're going to do is we're going to think about how I can do this and not necessarily have to use a number line to represent it, because I think that that's going to be a little bit easier for you guys to learn. So if I had 9 copies of 1/4, well, 9 copies of 1/4, really that's just 9 times 1/4. Now what they want us to kind of show is our 9 1/4. 2, 3, 4, 5, 6, 7, 8, 9. Now, I just wrote 9 1/4 out. Show you kind of an interesting little trick here is you could do that and then you could literally just draw your number line underneath. So if this was my number line, I can see, okay, if I grouped these by fourths, so there's 0, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So if that's my 0/4 there and that's my 9/4 there, I know what they've been asking me to think about is grouping my fourths in order to make a whole. Well, how many fourths are there in one whole? Well, we know one whole is the same as 4/4. So if I group and I go 1, 2, 3, 4, there's 4/4. That's one whole. And then I go 1, 2, oh yeah, look, 1, 2, 3, 4. Hey, there's my 2 wholes. But wait a second. This is the same as 4/4. This is the same as 8/4. But I have 9/4. So I have 4/4 2 times. I've got my 2. And then I still have this extra 1/4. And I'm going to make that kind of pop out with a color right now. That extra 1/4. So when I look at this, I can kind of see now that from here to here, there's my one group of 4/4. Here to here is my second group of 4/4. But I still have this little space right here. It's still a little bit more. So what I've now discovered is that I have 2 whole candy bars, but I have an extra 1/4. And I'm going to prove to you that that actually works. I'm going to use my whiteboard right now. I'm going to move that up for just a minute so you can still see it. But one of the things that we also learned was this idea of how to use division. So if I was trying to find 9/4, what I'm going to do is I'm going to divide. I'm going to say 4 divided into 9. Okay, I take my denominator, divide it into my numerator. How many 4s are in 9? 4, 8, oh, 12's too big, so it's 2. That means I have 2 whole amounts. That 2 becomes my whole number. Then, that 2 times 4 gave me an 8. I have 1 left over. That 1 that's left over, that 1 right there, that becomes my numerator. And then, as we know, my denominator stays the same. So what I'm doing here is I'm showing you that math way so that if you wanted to do the division to prove it, you could do that as well. So we're going to practice a little bit of both ways right now. So I've got mine, you've got yours. Okay, so the next problem that we're going to do, and I'm going to just get rid of that so you can see it a little bit better, is 7 times 1/2. So we're going to think about this as a problem that where I can use my number line. So I'm going to move that up a little bit. I'm just going to rewrite it. 7 times 1/2. Okay, so I know that right there would be 0. And I need 7 lines because I have 7 halves. So that doesn't count as my first line. That's 0. So then it would go 1, 2, 3, 4, 5, 6, 7. So I've just sort of put my 7 lines in. I know that they each represent 1/2. 1/2, 2 halves, 3 halves, 4 halves. Oh, I switched to fourths somehow. 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. So I can see that that did work. 1/2, another half. I keep going till I get to 7 halves. If I did 1/2 7 times, that would be 7 halves. So where it gets a little bit trickier now is in that grouping, because I have to group my halves to make a whole. So I ask myself, how many halves are in a whole? There's 2 halves. So from here to here, that's 2 halves. 1 half, 2 halves. There's 1 whole. And then I go to the next one, and that would take me to 4 halves. Again, 1/2, 1/2, 2 wholes. And then I jump to here. That's 6 halves, which is the same as 3. I can see 1, 2, 3, 4, 5, 6 halves, but I still have 1 more half, and it's not all the way to 4. Remember, 8 halves, that would be 4. So I'm not to 4. I'm at 3 and, yes, you guessed it, 3 and 1/2. So that's how I would use a number line to help me solve a problem like this. Now we're going to go back to the other paper for just a minute, because I want you to see that grouping idea that we just did. So again, I know that 7 halves is the same as 1/2 7 times. 1, 2, 3, 4. Okay, so if I look at this, I'm going to grab another little sticky note. I just don't want you to get confused by looking at all those numbers. So I want to make sure it's very clear to you. Okay, so again, multiplication, fast addition. So we know that gives me 7 halves. And I know if I grouped them, there's 1 whole, 2 wholes, 3 wholes. 1, 2, 3. That's 3 wholes, 3 2 halves. But I still have that extra half that I have to add on. So really what I've got going on right here is 3 wholes. 1, 2, 3. 3 wholes with 1 extra half. Do you see how that worked? Now if I did it the division way, well, guess what? 7 divided by 2. Well, if you think about it, 7 divided by 2, how many 2's are in 7? There's 3. So if I did that problem right up here, I would say 2, 4, 6. 8's too big. 3 was as close as I could get because 2 times 3 is 6. I had 1 left over. That quotient is your whole number. That remainder becomes your numerator, and your denominator stays the same. All right, so now I want you to try the next problem. So I want you to look at your number line, and I want you to try 13 times 1/5. So I'm going to erase this first one that we did, and we're going to do 13 times 1/5. All right, so if I was drawing a number line, I know my first is going to be 0. I need 13 fifths. So I know I'm going to need at least 13 lines. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh my goodness. It's even longer than what I had. So I have 13, and now I'm going to prove that they're fifths. There's 1/5, 2/5. You get the idea, right? 1, 2, 3, 4. Right here is where my 5/5 would be. And then I'd have 6, 7, 8, 9. Here is where my 10/5 would be. So 5/5. I'm going to make it so you can see that just a little bit better. So 5/5, 10/5. So from here to here is 1 whole. From here to here, that's another 5/5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Another 5/5. Now, 1, 2, 3. There's only 3. Oh, and that makes sense because 10 plus that 3 would give me my 13. That's where my 13/5 would be. So I have 2 whole amounts right here. There's my 2 jumps. 1, 2. And then I have 1, 2, 3/5 extra. 2 and 3/5. So again, that's what it would look like on a number line. You can see how that would work. What I want you to also practice is that concept. I'm going to move all this down again, of how I would write my fifths and group my fifths. It's just like what we did on the number line. 1/5. We're going to do that 13 times. And I know it's a lot to write out, but there is a method to the madness. If you get tired of writing them all out, you can do it on your number line, but you can also just do it this way. This is similar to doing it the number line way. You could do it this way, or you can do it on a number line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Uh-oh. I need 13/5. Now I have 13/5. Oh my goodness. That is a lot of fifths. And if I added all those fifths together, I would, of course, get 13/5. Okay? So if I want to group my wholes, I know I need to group them by 5. 1, 2, 3, 4, 5. Because that is 1 whole. And I take another 5. 1, 2, 3, 4, 5. There's another 5. So that would give me 10, which again would give me 2 wholes. And then I have that 3/5 left over. Okay? So as you can see, what I have here is I have 2 5/5. 2 5/5. There's 1 5/5, 2 5/5 with an extra 3/5 left over, which gives me 2 and 3/5. Because that 5/5 is just 1. 2 times 1 is 2 plus that extra 3/5. All right. The last one that we wanted to do was 17 1/6. That's going to be a hard one to draw. And I personally, drawing that on the whiteboard would be very, very challenging for me. I couldn't even make 13 fit, but we're going to try it. Here we go. So, again, on a number line, I would start with 0. And then I need to go, and this time I need to add 17 lines because I have 17 times 1/6. So I need 1/6 17 times. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So now I can see my number line has to be extended. There is my 17/6. If I counted them, 1/6, 2/6, 3/6, 4/6, 5/6. Oh, good, right there. There's my 6/6, 7/6, 8/6, 9/6, 10/6, 11/6. Oop, 12 sixths is right there. I wonder if I have another 6, because here, 1, 2, 3, 4, 5, 6. There's my 6 sixths. I know that that is 1 whole. If I keep counting, 1, 2, 3, 4, 5. There's another 6 sixths. That's my 2 wholes. 1, 2, 3, 4, 5. I did not get 6 sixths. I got 5 sixths more. So if I was going to write this out, and I really, it's torturous, I know. 1 sixth plus 1 sixth plus 1 sixth plus 1 sixth plus 1 sixth. Right here, I can see that that is 6 sixths. I'm going to do it again. All right, so here's 6 sixths. Here's 6 sixths. I can see that that's 2 times 6 sixths, which means it's 2 wholes. 1 whole, 2 wholes. But, that was only to 12 sixths. I still needed 5 more sixths. And I could see, if I, instead of doing a number line, if I needed to write out all 17 of my sixths, I could then group them. There's 6 of my sixths. There's 6 of my sixths. So that's 1, 2 with an extra 5 sixths. So this would be 2 and 5 sixths. If you wanted to do that the division way, one last thing, 17, whoops, I did that backwards. 6 divided into 17, 6, 12, 18 is too big. That's where my 2 comes from. That would be 12. When I subtract, I get a 5. The 5 is my remainder. That 5 is what becomes my numerator, and my denominator, what's it been the whole time? A 6. So, lots of different ways to represent this. You have now seen it on a number line. You've seen it grouping it algebraically, and you've also done some division to figure it out. I want you to do whatever works best for you to solve the problems on page 159 and 160.